Consider problem 1511. The mass in the figure below slides on a frictionless surface. When the mass is pulled out, spring 1 is stretched a distance x1 from its equilibrium position, and spring 2 is stretched a distance x2. The spring constants are k1 and k2 respectively. The force pulling back on the mass is, this is a kind of complicated situation. We're stretching spring 1 a distance x1, and then from that contact point we're stretching spring 2 a distance x2, and that's connected to the mass like this. So this is K1 and K2. If we were to try to describe this whole system, it could be a little bit complicated based on x1 and x2. But the question here is, what's the force pulling back on the mass? And like any problem dealing with a free body diagram, we just need to focus in on the mass in question. What is the free body diagram of that mass? Of course, it's got gravity, mg, and there's a normal force acting on it. And then the force pulling to the left is the spring. The only thing connected to it is the spring itself. And the spring has been extended a distance x2. So this force to the left here is equal to a negative k2 x2. That's the only force acting on it. And that spring has been extended that distance, so that is the force that the spring is acting on it. So sometimes we just have to take a step back and just look at the free body diagram of the mass in question, and everything else in this case is immaterial as far as this question is concerned. What is the force acting on the mass pulling it back? It's simply the spring force, negative k2 x2. Answer.